This is David de los Reyes. My topic is integration by algebraic substitution. Okay, we shall start. Our topic is integration by substitution. The first substitution is algebraic substitution. Okay, I will give you an example of integration by algebraic substitution. Example number 1. The integral of x, the square root of x minus 2 dx equal to. We will introduce a new variable for the solution, okay? Okay, let's proceed with solution. We let z equal to the square root of x minus 2. This is the algebraic substitution. Yes. Why algebraic? It's not exponential, it's not trigonometric, it's not hyperbolic, it is simply z. So this is algebraic substitution. We let z equal to the square root of x minus 2. Square both sides. Squaring both sides. C square equal to x minus 2. Okay. This is actually x minus 2 raised to the 1/2. Okay. Then we will square again. Okay. These two here cancel with this. So what remains on the right hand side will just be simply x minus 2. X now will be c square. We transpose this to the left. This is plus 2. Compute for dx. Dx is equal to 2z dz. Power formula plus 0. Dx is 2z dz. Okay? Substituting. That's why the solution is by algebraic substitution. We now try to substitute the resulting value of dx back to the original equation. As simple as that one. Therefore, the integral of x, the square root of x minus 2 times dx equal to the integral. What is x? X is actually the square root of x minus 2. What is x? Oh, this one. Sorry for that. The value of x is actually z squared plus 2. Okay? We are substituting. Times the value of x. What is x? What is the square root of 2 minus x? It is z. Okay? We are just following this. We are replacing the value of x and this value here in dx as a function of the new variable. So, x is actually z squared plus 2. Okay? Times z. What is z? Times z. Okay? Times the value of dx. What is the value of dx? It is 2z dz. Okay? So after the substitution, what comes out is a function as a function of the new variable. Okay? Simplifying this will now be, we got a common factor, common constant 2. I bring it out, the integral c squared times z is actually c to the 4th, and 2 times c is actually 2z squared dz. Okay? This is now the resulting integration on the right hand side. Okay? If we try to look at it, it all falls under the power formula. Okay? Where the value of u for the first one is z, du is dz, it is exact. Second one, constant in the function. U is z also, du will be dz, so it will be exact. So the integration of the right hand side after the substitution as a function of the new variable, this will now be 2 open bracket power formula z raised to 4 plus 1, which is 5 over 5, plus 2 times z raised to 2 plus 1, which is 3 all over 3, close bracket, plus c. Simplifying the coefficient, this will be 2 over 5 c to the 5. 2 times 2 is actually 4 thirds z cubed plus c. This is now our final answer as a function of the new variable. So to solve the problem in terms of x, we will just place the value z equal to x minus 2. That is our algebraic substitution. Okay? Therefore, the final answer now will be equal to 2 over 5. What is z? It's x minus 2 raised to the 1/2, raise that again to the 5th power, plus 4 thirds, okay, times x minus 2 raised to the 1/2, raise that again to the 3rd power. We are just following this, plus c. Final answer, 2 over 5, okay? 1/2 times 5 is 5 halves. So the exponent of this one now will be x minus 2 raised to the 5 halves, okay? 4 thirds. 1/2 times 3 is 3 halves. So the second part of the answer is 4 thirds, x minus 2 raised to the 3 halves plus c. This is the final answer in terms of the original variable x. That is solution by algebraic substitution. We introduce a new variable for the original problem to be more easily integrable. That's the significance of the so-called integration by substitution. But our main topic is algebraic substitution. So it's up to you to choose which part of the integration you will represent with the new algebraic substitution. Okay? Okay, let's continue. Example number 2 under algebraic substitution. The integral of dx over 3 minus 2x raised to the 4th power. This is under the denominator equal to. Again, the solution will be algebraic substitution. I will let z equal to 3 minus 2x raised to the 4th power. I will let the denominator as z, and that is our algebraic substitution. Yes. Okay. Let's compute for the value of x. Okay. Take the 1/4 power of both sides. Right? C raised to the 1/4 is z raised to the 1/4. Right hand side, 3 minus 2x square, raise that again to the 1/4 power. This 4 here cancel with this. Okay? So the right hand side will be simply 3 minus 2x. And from that, we can now compute for the value of x. Algebra. Okay? We transpose this to the left. Okay? Then we transpose this to the right. So 2x equal to 3 minus z raised to the 1/4. Dividing all terms or multiplying all terms by 1/2. Algebra. 2x times 1/2, this 2 here cancel with this. Left hand side will just simply x equal to. The right hand side should have a coefficient 1/2 because we will multiply that by 1/2. So dx, x now will be equal to 1/2, open bracket, z 3 minus 2 to the 1/4. Okay, that's the value of x in terms of z. We need this one later on. Okay, try to compute for the value of dx. Dx equal to 1/2, constant, this is a function, so this is 1/2, derivative of 3 is 0, z to the 1/4, we differentiate power formula. So this is minus 1/4, z raised to 1/4 minus 1, or 1/4 minus 4/4, it's minus 3/4 times dz. So 1 times minus 1 is minus 1, 2 times 4 is 8. Therefore, dx equal to minus 1/8, z raised to minus 3/4 dz. Okay? That is the value of dx as a function of the algebraic substitution z. Therefore, the integral of dx equal to integral of dx over 3 minus 2x to the 4th power equal to, what is dx? It is this. Okay? And what is the bottom portion? It is z, right? So simplifying, we got the negative 1/8 here, this is negative 1/8. The integral of z raised to minus 7/4 dz. How come it is minus 7/4? The numerator is z raised to minus 3/4, right? All over z. Z is actually z raised to the 4/4, right? And if we simplify this will be z raised to minus 3/4. We bring this up, so this is z raised to minus 4/4. Same base, different exponent, it will be same base, then add the exponent. Minus 3/4 minus 4/4 is minus 7/4. It is this. Right? And if we try to integrate this one, easy money, power formula. This is minus 1/8, z raised to minus 7/4 plus 1 over minus 7/4 plus 1, close bracket, plus c. Simplifying, this is minus 1/8, minus 7/4 plus 1 is actually 4/4. Minus 7/4 plus 4/4 is minus 3/4. So this is minus 3/4, close bracket, plus c. Simplifying further, this is minus 1/8. Okay, we take the reciprocal of this. So we could multiply this on the numerator. So this is minus 1/8 times minus 4/3. The reciprocal of minus 3/4 times z raised to the minus 3/4 plus c. Okay. This 4 here cancel with this. Bottom portion will be 2. Okay? Negative 1, that will be plus 1. 2 times 3 is 6. So the coefficient of the final answer will be positive 1/6. 3 minus 2x raised to, what comes out is, this one. That is in terms of z. We try to, I will erase this one. I will issue the simplification. So the final answer in terms of x will be equal to 1/6, right? Times the value of z. What is z? Z is actually this one. 3 minus 2x rose to the 4th power, okay, raised to, that again, to the minus 3/4 plus c. So actually this 4 here cancel with this. So our final answer will be 1/6, 3 minus 2x, okay. This cancels out. What remains on the exponent of this is minus 3. This is minus 3 plus c. So this is the final answer in terms of x. That's it. So after the algebraic substitution, taking the differential of dx as a function of the new variable, we will substitute it, we will simplify it, and we will try to see if the resulting integration will be integrable. And if it's integrable, proceed with the integration, okay, to bring out the final answer in terms of x. Just take your original substitution, put it back, and that is the final answer. That is solution by algebraic substitution. We introduce a new variable for the resulting integration to be much simpler. Thank you.